Here I've set up an experiment. I've got a meter rule. The mass of the meter rule is 130 grams. 200 gram masses have been attached to the meter rule. This one is centered at 20 centimeters, or the 20 centimeter mark, and this one is centered at the 70 centimeter mark. The meter rule and the masses are supported by two force meters. This one is supporting at the 10 centimeter mark and this one at the 90 centimeter mark. The aim of this experiment is to calculate the forces that we would expect these two force meters to be showing. Just a note about using force meters. These are quite difficult to calibrate, and I found that the best way is to take a known mass, which I've got here of 300 grams, and I can see that on this one that I'm holding up there is a reading of about 3 newtons, which is what we would expect. So calibrating these force meters with a known mass is quite a useful way of starting something like this. So given all that information, I'm now going to do some calculations. The diagram shows the forces acting on the meter rule. There is the tension from the left hand force meter, a weight of 0.2 g to the 200 gram mass, a weight acting at the centre of the ruler of 0.13 g for the weight of the ruler, and the weight of the other 200 gram mass, and then the T2, the tension from the right hand force meter. These are the distances between each of the forces. So I'm going to take moments about this point O. These three forces will produce clockwise moments and T2 will produce an anti-clockwise moment. So starting with the anti-clockwise moment, I have the force T2 at a distance of 80 centimeters. So that will be the total of the anti-clockwise moments. Then I will have 0.2 g times 10 plus 0.13 g times 40 plus 0.2 g times 60. Completing the calculation gives a value for T2 of 2.4 newtons. As the downward forces must balance the upward forces, T1 plus T2 must be equal to 0.53 g, and using this equation you can show that T1 must be equal to 2.8 newtons. Zooming in on the left hand force meter shows a value very close to the 2.8 that we predicted. Similarly, looking at the right hand force meter, where we predicted 2.4 newtons, again you can see we're getting quite a reasonable answer. If we look closely at the end of the meter rule, you can see that it's had a hole drilled in it, which would actually slightly affect the position of the centre of mass of the meter rule. This could explain why there is a small discrepancy in the values that we obtained.